As we get more data from all the sequencing, I think we should find a way to put this in an accessible format. The first thing is storage, second thing is analysis, and third is making it available to the community. And I'm very pleased to say that the National Institute of Health in the US is really working hard on this, using this knowledge network. And one example is the use of the Genome Data Commons. And these are available, through a cloud-based system and various tiers of access. And I'm very confident that, the research community will start using it over time. But I do think this brings up an important point that as we have more complex data mined, we're going to really have the storage a big issue. It's no longer enough to store it on a server, and we got to keep it, house it in a place where it can be accessed. So the information as is being gathered now has reached a point that it is really, I think it just not the genomics or the cancer community, but I think the larger world, as we get more information, how to store them more effectively. I bet that future technologies would be able to compress the data in a smaller, space. But I certainly think it is going to be a huge challenge. I think there are two initiatives, I would say, in the short term. In fact, President Obama unveiled this in the State of the Union speech 4 years ago, where he launched this personal medicine initiative. The short-term goal is to focus on cancer, and the long-term goal is in other diseases, including diabetes and other common diseases. And the first one is, of course, spending more money and infrastructure and resources for cancer genomics, continuing the work of the previous project, the Cancer Genome Atlas project. And now there are efforts to really map out the human tissues, human cancer, the human tumor atlas. That is a big effort. There's also a big initiative using patient-derived xenograft, really mapping out the genomic alterations in the tumors as they evolve in these xenografts in mice. And of course, a lot of initiatives currently ongoing to study the targeted agents in special populations using those umbrella and their basket studies. And then the other initiative, which is a non-cancer initiative, is this project called All of Us, which is a big project that is currently ongoing, where individuals would be able to upload their data from the electronic mobile devices and through the doctor's office's electronic health records and contribute tissue specimens, blood, urine specimens, and this will be sequenced to a great extent, and future technologies would allow additional analysis to be done to identify why some people are at risk for getting some diseases, why some people are actually uniquely prone to not getting these diseases, and can we understand this complex disease process. And I would encourage people to go and look up the website, All of Us, through the National Institute of Health in the US. And it's going to be an impressive effort to identify and collect data from 1 million individuals, including over time pediatric population as well. I think there are two parts to this. One is the discovery, another is implementation. I think the discovery piece involves finding new tools and technologies to identify, what are the key alterations at the DNA, RNA, and the protein level. Well, we've done a very good job with the DNA alterations because we always have a tumor normal pair in cancer. RNA technology and identifying the alterations at the RNA level is lagging a little bit behind, in my view, partly because we don't have the matching tissue for RNA analysis all the time. The other big challenge is to understand the alterations at the protein level, and I think that's also moving forward. And for example, in lung cancer, we are starting the proteomic analysis of nearly about 100 lung cancer tumors that will be integrated with genomic alterations at the DNA, RNA level. I think we will understand better the proteomic alterations in the coming years, which I think is significant and very, very important. The second challenging piece is how do you move forward to the community, making the test accessible in a cost-effective manner. How do we get the drugs to the right patient at the right time in a cost-effective manner? Cost is going to be a bigger issue, both for the drugs, the testing, as well as the hospitalization costs. And that, I think, the community around the world needs to come together to deliver these great advances in therapy at an affordable rate. And that's a huge challenge.